Now, all of these slides so far have talked about one specific bug, but what about if we talk about every bug? And so we switch tack a little bit. And now we talk about the microbiome. And I think everybody in the room understands what the microbiome is. And you all also know that if you compare, let's say, the output from culture-independent methods in terms of identifying bacteria versus the traditional culture-based approaches, there's a gulf of a difference between them. So in terms of culture-independent methods, or so-called next-generation sequencing methods, we can take any sample we care to think about, isolate nucleic acid, sequence it to totality, and then run it back against various databases to identify the nature of the sequences that have been read through whatever platform we've used. So this is particularly useful in looking at fermentations and in looking at the dynamic of a fermentation over time. It could be particularly useful to what Marion was talking about this morning in terms of looking at the metagenome of those different plant-associated backgrounds that she was commenting upon. And in fact, it also is very useful in terms of helping us to manipulate this, because we could, for example, put pathogens in or put probiotics in and see what it does to the metagenome by way of the changes in the dynamics of the sequence. We could also use this for biological control, so that instead of being mandated by the regulator to look specifically for Chronobacter or Salmonella, potentially we could use a shotgun sequence approach to look for every bug and to decode that information when Chronobacter is present and compare it to decoded information when Chronobacter is absent, and look for those differences which might be indicative of natural biological control phenomena that might just be happening at the level of the plant. That could be extremely useful because it could immediately remove the need, assuming it's validated of course, for the use of chemical disinfectants.